All right. So this is what I said we were going to do. New program, still a single instruction, still just microcode, but the program is read program counter, write to the address register. So this is the RAM address register. So this is actually the address bus. So we're taking the program counter and we're setting the address bus to the program counter. Then the next instruction is read the contents of the RAM pointed to by the address instruction, or the address register, and put that into an output on the I/O. So this is random data that's inside the RAM chip. Here we have a lot of zeros. And at other addresses we had other things. Oh, I know what was going on. Remember we had the low bit. So we have 128 bytes of ROM and 128 bytes of RAM. So right now we're looking at ROM because the last bit, bit 7, is a 0. And so our ROM is just reading out all zeros. And then when we finally get to 128, we'll start looking into the RAM space. So right about now, and here we're looking into RAM. So we have random data in the RAM. So that all seems to be working great. Program counter works, address counter works, addressing scheme works. The RAM seems to function. We can go to the next step, I guess, which is writing a program and putting it in ROM and then trying to execute it by transferring, having the program counter take the ROM, stick it into the instruction register, execute that instruction, then increment the program counter, which increments the ROM. We'll go to the next instruction, so we'll execute instructions. Those instructions, we will need to program the microcode with various instructions. So right now our instruction is always 0, 0. We can make it simple, then we can create an instruction for 0, 1 and a different instruction for 0, 2. And then eventually we can put the ALU back in and start doing math as well. But what I'd like to do, get to the point where we can execute different instructions and have it do different things. And then the final instruction that I would like to be able to execute is a jump instruction. So the jump instruction would take contents of ROM and do a write instruction to the program counter. So right now all we're doing is increasing the value of the program counter. In order to do a jump, we would need to take some value that's stored and load it into the program counter, and then it would cycle through a certain number. So we could have, like, say, a 5-step program, and on the 5th step the program counter would load the actual program would load the program counter with 0, 0, and it would cycle back to 0, 0 after 5 instructions. So that's where we're headed. But at least right now everything seems to function great. Still don't know why we have to do that double pulse, but it does seem to work.